Hi there. In this video, I will be introducing the drilling and tapping operations using a lathe machine. A tapping operation is used to create an internal screw thread in a material. Before any drilling operation, facing must be completed on the end where the hole is to be drilled. To begin the drilling operation, first, set the speed range on the lathe machine to high. Secondly, clamp the workpiece onto the chuck. The workpiece must be extended at least a thumb's width from the chuck. Thirdly, mount the drill chuck into the tailstock. Ensure the tailstock quill is extended before inserting the drill chuck. Pull the drill chuck to ensure a positive mounting. Finally, mount the center drill into the drill chuck. Ensure the drill chuck is fully tightened. A center drill is used to create a pilot hole, before using the twist drill to prevent the twist drill from deflecting. It can also be used to create a center hole for a dead or revolving center to support a long workpiece. Once ready, switch on the spindle and set the correct spindle speed. The spindle speed is dependent on the workpiece material and drill bit diameter. Bring the tailstock to the workpiece till the center drill bit is close to the workpiece and lock it into position. Slowly extend the quill. As the material is being drilled, stop and retract the center drill regularly. Stopping the feed will break the chips to prevent jamming and drill bit breakage. Retracting the feed helps to evacuate the chips. Drill to half of the center drill taper length. When drilling a center hole, drill sufficiently deep to have the most tapered surface as possible. This helps when the center is used. However, do not drill beyond the taper on the center drill. After drilling the hole, retract the quill and the tailstock. Then switch off the spindle. Replace the center drill with a twist drill of the needed size. Ensure the drill chuck is tightened fully. Once ready, slide the tailstock forward till the drill bit is close to the workpiece and lock the tailstock into position. Next, extend the quill till the drill tip is at the entrance of the pilot hole and lock the quill. Then zero the tailstock quill. Zeroing the quill is useful when monitoring the drill depth. Ensure the twist drill is at the start of the pilot hole, either by sliding the tailstock or extending the quill before locking the tailstock and quill. To zero the quill, rotate the dial to align its zero mark to the datum mark. Finally, unlock the quill. Then, switch on the spindle and extend the quill slowly. As the material is being drilled, stop and retract the quill regularly to break the chips. This process is called chip breaking. Notice how the tailstock hand wheel is rotated to achieve chip breaking. Keep track of the number of turns the quill hand wheel is rotated, and read the dial to attain the measurement. Ensure that dimensions are added up till the desired drill depth is attained. After drilling the hole, retract the quill and the tailstock. Then switch off the spindle. To measure the depth of a blind hole after drilling, use a twist drill of the same size of the hole or slightly smaller and insert it fully into the hole. Rotating the drill bit by hand allows easier insertion. While holding the drill bit, place your thumb at the hole entrance. Take out the bit and use a vernier caliper to measure the length of the bit from the drill tip to the location of your thumb. Sometimes, a larger hole needs to be drilled. Drill a center drill before switching to the larger drill bit. Ensure the drill chuck is tightened fully. As the twist drill is larger, having a high spindle speed will not produce an accurate hole. Lower the spindle speed and feed the drill bit in slowly. If needed, add some coolant. Remember to drill using chip breaking method. Stop and retract the drill bit to break and evacuate the chips. If drilling is required on a long workpiece, clamp the workpiece as short as possible to reduce material overhang. Tapped holes are needed to use a screw fastener on the workpiece. Before any tapping operation, a hole must be drilled. The tap size determines the size of the drilled hole. For example, to tap an M3 screw thread, a diameter 2.5 mm hole must be drilled first. Furthermore, the hole must be at least 5 mm deeper than the tapping length to ensure the screw thread is fully formed. After drilling the hole, use the tap set and tap wrench to create the thread. The tap set has 3 bits. The number 1 bit is called taper tap, the number 2 bit is called plug tap, and the number 3 bit is called bottoming tap. Regardless of tap size, all hand tap sets have 3 bits. The taper tap has the longest taper in the front. This allows the tap bit to be aligned in the hole. As the bit is rotated, only some threads are formed at the top of the hole. The plug tap, which has a shorter taper than the taper tap, forms threads further down the hole. The bottoming tap has the shortest taper, and it creates the threads as deep as it goes. It is important to be able to identify and use the tap bits in sequence. If the bottoming tap is used first, the screw threads may be deformed, as there is insufficient taper length to help you align the tap bit to the hole. Each tap bit has a square end, which fits into the tap wrench. Loosen the locking handle of the tap wrench to open the clamps. Place the tap bit in the tap wrench and rotate the locking handle to clamp the bit into the wrench. Ensure you align the square end to the square clamps correctly. Place the taper tap bit into the hole, and use the taper to help you align the tap bit to the hole. While maintaining perpendicularity, gently press and rotate the wrench into the hole. It may take a while for the tap to bite the material and form a screw thread. You will need to feel for the resistance of the tap forming the material. Once the tap starts forming the thread, reverse a quarter of a round for each half a round. This way the chips are broken. If it gets tougher to rotate, it is good practice to reverse, remove, and clean the tap bit of chips. Do not force if the tap bit is stuck. Rotate clockwise and counterclockwise repeatedly to break and clear the chips. Excessive force will break the tap. Use cutting fluids to reduce cutting force and improve surface finish. Once the required depth is reached, reverse the bit. Do not force if the tap bit is stuck. Rotate clockwise and counterclockwise repeatedly to break and clear the chips. Support the bit as it comes out of the hole. It can fall off from the tap wrench and break apart. After completing the hole with the taper tap, clean it thoroughly, and continue with the plug tap. As there are some existing screw threads in the hole, it is easier to screw in the plug tap. However, once the rotational resistance increases, repeat the action of reversing a quarter of a round for each half a round. Lock the locking handle if it comes loose during tapping operation. Once the desired length is reached, reverse the tap to remove it. Repeat this procedure with the bottoming tap. After completing the screw thread, test it with a screw. Ensure there are no difficulties when inserting the screw. If needed, knock or blow out the chips that may be stuck in the hole. The demonstrations you saw are the typical drilling and tapping operation for various workpiece sizes. Ensure you are aware of the cutting speed required for the workpiece material and drill size you are using. Cutting speeds for aluminium and steel are very different, and using the correct speeds will improve your machining time and quality. Speak to a SP staff if you are required to drill or tap steel.